Okay, so here we have something called the principal diagonal. Nothing much to do with that. Just so you know, the principal diagonal is just the diagonal extending from the upper left corner to the lower right corner. So this right here is called the principal diagonal. And you can see there's a bunch of ones there, right? Now, let's take a look at the identity matrix. The identity matrix is a matrix that looks like this. It's a matrix with a bunch of ones and zeros, but more specifically, the ones are in the principal diagonal position. Before I talk about inverse matrix, let's do just a little bit of general stuff. Let me go to a text box. And there's a property you guys have heard of, maybe not familiar with it, but it's not too hard. Something called the multiplicative inverse. Oh, sorry, multiplicative identity. That's what I meant to say. So what if I had x times 1? What would that equal? What's x times 1? X. Yeah, exactly. So anything times 1 is always itself. Yeah. Any number times 1 equals itself. That's called a multiplicative identity. And that's what's happening here. If I were to multiply this is just an example. I'll put some random numbers in here. Say I have like -1, 2, 5, 2, 10, 1, 6, 8. You don't have to write these down, by the way. But if I were to actually do that, if I actually were to multiply this this identity matrix with some random matrix that I just wrote, guess what's going to equal? It's going to equal the same exact thing. And here's the reason why. Great question. And this is why I was so hell-bent on you guys knowing to multiply matrices today, because we need it for today's lesson. What if I multiplied this row with this column? So what do I get? I get 1 times -1 is -1. And what's 0 times 2 and 0 times 6?
0.
You get -1.
You get the same thing.
What if I do the first row of the second column? 1 times 2, 2 with a bunch of zeros, right? And so forth. So that's why it's called identity matrix, because any matrix you multiply to identity matrix will be the matrix that you had originally. No matter what.
What about in the number 1 at the end of number?
Exactly. An identity matrix, it has to be set up that way. Right? So that's just something to keep in mind, because we're going to use this to help us with the problems later on today. All right. Now let's talk about what an inverse matrix is. An inverse matrix, and this is a formula, by the way, and this is, I will give to you guys. You don't have to memorize it. And it's denoted by this symbol that has a -1 as an exponent. It's just the inverse. It's like an inverse function in a way. It's just this right here. And this expression so happens to be the determinant of the matrix, which we talked about last Thursday. Determinant of a 2 by 2 matrix. Okay. So we're going to use this formula for the 3 examples down below. So let's do those 3 examples right now. I'll leave it positions like this. All right. So R equals this matrix. We want to find R -1. R -1 is the inverse. So I'm just plug and chug. That's all I'm doing. Plug and chug. So find R -1. You do this. Okay. Multiply diagonals. What happens when I multiply diagonals? -11, right? And then minus -10. That's part of the formula that you see up above. And then you have to swap these terms and change the signs of the other ones. So now that becomes 1 over -1. -1, 5, -2, 11. Distribute it, that should be pretty easy. That should be what, 1, -5, 2, and -11.
Oh, that's not.
So there's inverse. Now this part you don't have to write, but I want to show you guys. What was that? It is kind of whack, but let me show you something that will be very helpful.
Oh, it's just minus the multiple. Okay. No, got it. No, I get that. Where did the negative?
Oh, that's 2 times -5.
Because it's diagonal.
I'll multiply that diagonal BC.
Oh,
Right. Okay, so now let's verify our work. What if I take the original matrix, right? I know the original matrix is this, right? And let's take the inverse, which I'll draw in blue, which you know is this. What if I multiply these two together? What would happen? I should get 1, 0, 0, 1. So let me get a highlighter here. What if I multiply this row with this column? What do I get when I do that? I get 11 plus -10. I need a lower space here. Let me clear that out. $11 plus, and then repeat it again. You get -55 plus 55. And then if you do the second row with the first column, you get 2 plus -2. And then you get -10 plus 11. Okay, what results after you do this? You get 1, 0, 0, 1. As you should, because this is the inverse of this. When you multiply something by its inverse, you get 1. So for example, what's a multiple, like, what if I do 5 times 1/5? What's 5 times 1/5? 1.
1.
Because 1/5 is a multiplicative inverse of 5, right? They're opposite of each other. So that's kind of the same thing. If you take this matrix, if you take a matrix multiplied by its inverse, you wind up getting to the identity matrix, 1, 0, 0, 1. So Yami, go ahead. Oh, this right here? Oh, that's a diagonal. I did 2 times -5. So remember, you do this diagonal, which is -11, and this diagonal, which is -10. You subtract. That's part of the formula up here. AD, that's AD, that's BC. So you multiply these two together, which is -11. Yeah, that's all. No, good question. Ask questions, because there's a lot going on here. So that's how you find the inverse. And we're going to use this to solve a system of system of equations in a few minutes. All right, let's talk about example 2. Example 2 I'll tell you right now is does not exist. You can say that too. That also works.
Yes, I thought it
And why?
Because when you
was 0.
like turn it around the bottom, it's 0.
Yeah, because when you do when you multiply the diagonals, you have -7 times 27, but then minus 27 times -7, which will end up becoming -189 plus 189, which of course is 0.
0. Okay.
So, I mean, of course you have all this too. I mean, you could swap these two like we should and negate these and change the signs of these, right? But what's going to happen is you have 1 over 0 times all that junk, which means it does not exist. So that's the problem. Okay, let's try one more. Let's look at example 3. No, with the lower left corner. Yeah, so you swap. So what you do is you let's do it for the other one. It'll make more sense. Yeah. Okay, let's look at example 3. So 1 over what? What about guys? What am I put on the bottom here? Thank you, Maggie. She should get 1/3 on the bottom. And here, okay, now very careful. It's just following the formula. You swap -9 and 5. They swap positions. And what do you do about 6 and -8? You change the signs, exactly. Okay, cool. Yeah, and that's what you get. Okay. All right. Now, how are we going to use this to solve a system? I'm going to show you in just a sec. All right. At the bottom of the page, it says here an inverse will not have a matrix when which of the following happens. When AD minus BC, yeah. When AD or the determinants so that's how we know we don't have matrix. Yeah. You all go? Okay, cool. Good luck to you.
Thank you.
All right.
You guys lost it? No, we have not.
And by the way, we're gonna cross off example 7 and 8. We're not gonna do them. So we're just gonna do this page and be done with the notes today. Okay. Okay. You guys, stop talking. Eric, stop. Eric. Yeah, let's focus here. Thanks. Okay, so you're asked to write the system here as a matrix equation. So here's how you do it. You can write it like this. You're welcome. Okay, let me have you copy this down first. I'll explain what happened. Okay, here we go. What just happened? Okay, guys, quiet, please. So you got two equations, two variables, right? Now, what I'm doing is I'm deliberately making a matrix equation out of it. So I have a coefficient matrix, which is this right here, -2, 3, 5, 7. I have a variable matrix, which is called XY. I have a constant matrix, which I call 9, 6. How did I do this? Well, if you look at the first equation, what's the coefficient of X here? -2. What's the coefficient of Y? So hence -2 and 3 from the first row.
Ah, gotcha.
Now this is tricky. 7y plus 5x. So I made that kind of mistake in the homework solution key for last night or for the weekend. So you got for the 5 first, and then the 7. And then if you move the -4 to the right side, you get 6, right? That's why we have a 6 here. So that's called a matrix equation. What we need to do is build matrix equations from the system of equations, then use an inverse to isolate x and y. That's what we're going to do. So let me actually write that out, because that's actually really the whole essence of this unit, or this lesson. Create a matrix equation from the system of equations, and then use an inverse to isolate x and y. Let me resize that. I'm doing good.
After this, you know, we're gonna have to use matrices and limits like after this,
I don't know what other unit we're covering after this. That's kind of bad. I think we're doing logarithms and I mean here Well, actually, maybe not. No, I lied. I don't know. I think just general functions. I mean, the thing about pre-cal in the second or usually this is covered in the fall, but one of the semesters of pre-cal is kind of a hodgepodge of different topics, so that when you move on to calculus, that these don't become an issue. That's really now this stuff actually you probably won't see again until beyond calculus.
Okay, stats.
A course called linear algebra, which usually like economics majors take. It's another subset of math. Yeah. Usually they do take they tend to use matrices often in their math courses. Yeah. You'll be fine. You guys will be fine. All right. Anyway, so let's look at exam 5. And this is where matrix multiplication is going to matter. All right. So let's make another matrix equation here. 3, 1, 4, -2. X, Y, -8 and -14. Okay. Let's take a look what's happening here. Why does this make sense again? Because what if I multiply this row? And you don't have to circle these, by the way, but what if I multiply that row with that matrix, right? What would I have? I have 3x plus y, right?
Yeah.
What if I multiply this row with that column? What would I have? 4x minus 2y. And what do I have on the other side? -8 and -14. So that's why it's good to know matrix multiplication so you can make sense of why this works. Because that's a 2 by 2 matrix with a 2 by 1. So the inner dimensions match up, giving you the 2 by 1 over here. So matrix multiplication is the reason why this setup makes sense. Now, matrix multiplication also helps us how to solve this. So how do I solve this matrix equation? How do I get x and y by itself? Here's what we do. You do the inverse, right? I'll show you I'm gonna show you how it looks. I'm gonna copy this again down below. All right, so 3, 1, 4, -2. I'm gonna copy right here. X, Y. All right, now what I'm gonna sneak in here is this. I'm gonna do it in red. Okay. This right here, the red matrix, is the inverse, yes. Of 3, 1, 4, -2. Okay. So let's do it. Let's actually find this inverse. It's not that hard. I'll do it off to the side here. Okay, how do I find that inverse? What do I do? What do I put on the bottom here? 1 over multiply the diagonals. -6 minus 4. And I'm going to multiply it. I reverse -2 and 3, right? And I change the signs of these here. What does that become? -1/10 times -2, -1, -4, and 3. And what does that equal? 1/5. 1/10, 2/5, and negative 3/10. So now you're going to use that down here. Now, when I write my answer, sorry, when I work this out, I'm going to write in my inverse, which is this. And what's happening is that all this right here, what does that equal? What happens if you multiply the inverse by itself? We talked about this about 10, 15 minutes ago. It's equal to the identity matrix. What happens when you multiply something by its identity? Does it ever change? No, right? We talked about the identity, multiplicative identity. When you multiply something by 1, it stays the same. So this actually goes away, but technically what's happening is that when you multiply something by its inverse, it becomes this. If I multiply this xy, you just get xy. That's all. And then you have to do this multiplication off to the right because you have to do it to the same side. If you work it out, just I already did this in the other class, so just trust me that I've got this. It's negative 3 and 1. But when you multiply, we know again, you multiply this row with this column. If you multiply that together, you do get negative 3. And if you multiply the second row with that column, you get 1. So I'm pretty sure I got that right. Yep, I got it. 100% sure. So that's how you use an inverse to solve a system equation. So like those if you have like a programming calculator that solves the system of equations, it actually does this. This is what it's doing. It's actually doing, it has matrices built into it. No, because you have to understand the process. Okay. We'll do one more so you guys get the hang of it, but I won't be as drawn out with it because I don't always have to write the inverse symbol. I can just do it and then just multiply it to the other matrix. But it's like division, right? It's like division. It's kind of like, how do you get this matrix over to the other side? You have to multiply by its inverse. And matrix multiplication order matters. So you have to make sure you multiply the top. So if we're multiplying to the left of this matrix, multiply to the left of this matrix also. Because matrix multiplication is not commutative, right? The order does matter. All right, let me go and can I clear this? Yes. Yes? Okay. And this is being recorded too. So let's try it one more time to get the hint, but I won't do this drawn out for example 6, and then you guys can get a head start on homework. So this will be 3, negative 6, negative 3 and 5, right? Because it's reversed. XY equals 15 negative 8. All right, so now if you want to get XY by itself, you got to do the inverse over here and multiply the 15 negative 8. So we'll do the inverse off to the side. Not yellow, that's a terrible color. Okay, let's do the inverse. What do you get when you do the inverse? 1 over what? -15 minus 18, thank you, Ella.
Yeah.
And what are you going to swap? And change the signs of, so it's negative 1/3 times that matrix. And what does that equal? Negative 5/3, negative 2, -1, -1.
Wait, why do you switch the sides?
That's just part of the formula. So I don't know. Good question. I don't know. And if when you multiply it out, which I didn't leave myself enough room, lovely. I'll do it over here. Again, just kind of trust me that I've got this. I'm doing this in my head. Should have on the board over there. I think it's -25 plus 6. I think it's -9. And the other one's going to be line -7. Is that right? Yeah. Cool. Yeah, that's it. So x equals -9, y equals -7. So let's not do example 7 and 8. I think it's a little much. The rest of this packet is homework, but don't do 5 and 6 though. Cross off 5 and 6 on the homework. I even said so in Schoology. So you need 1 through 4 and then 7 through 12, I believe. So if you guys want to get a head start, we got another 15 minutes or so. Or if you want to relax, it's been a long day, that's fine too. Yep. Three by three, no, because I'm not having practice it.
Okay.
Yeah. I mean, like these examples. Oh, the question. No. But so if you look at Schoology, like the list of topics that I put up there, like that's like your study guide, like all these topics, which I say use numbers for a 2 by 2, but not for a 3 by 3. Yep.
We don't do the rest.
We're not doing those examples, but then the homework is in the packet itself. So.
Do my knowledge project. Lisa? What? What? You know what? You just can see the classes. Hey, do you know when that too? We're already out.